All right, welcome back. So now we're going to talk about chapter 2, which is going to be a review of fractions and operations with fractions. So first, let's talk about what a fraction is. If you watched the last video, we very briefly looked at a fraction. Fraction is just a division problem, just written differently. So let's look at 2/5 or 2 divided by 5. And actually, I'm going to make that a little bigger so that I can make sure you at home can see it. So 2/5. All right. So many of you know how to read these numbers. You know what it means. But let's just talk about it. So a fraction is made up of two parts. It's made up of a numerator and a denominator. All right. So we have a numerator and we have a denominator. So our numerator is called a numerator because it tells you the number of things you have. Denominator comes from the word meaning of a name. So this is the number of a certain name. Or you can think of it as a number of a certain type. So 2/5 is really 2 of the fifths. Right? Because we have how many fifths? We have 2/5. Right? And that's why you read it that way. And that actually helps understand how we're going to have to add these things together. For example, if I have 1/5 plus 2/5, well, obviously I have 3/5 in total, right? Because I have 1 of the fifths and then I have 2 more of the fifths, so I have 3 of the fifths in total. So 3/5. So that's why it was always important to have the same denominator, because they need to be of the same type. They need to be of the same name. Now, some things can change the way they are. A lot of numbers can change the way they look just by you manipulating it a little bit using multiplication or division, or even addition or subtraction, as long as you do it to do the same thing on both sides of it, because that's to stay the same value. So, with that being said, you are always taught that if you have different denominators, you need to change it first. Well, how do we change it? So let's say I have 1/2 plus 1/3. And I want to add these two numbers together. So 1/2 plus 1/3. Well, they are of the same name. They are of the same type. So in order to add them, I'm going to have to change them so that they are of the same name, of the same type. And you were told to do this, you needed to find the least common denominator or the least common multiple between your denominators. So a number that both of these numbers are a factor of. Well, finding the least common denominator helps out a lot, for the reason being it helps simplifying at the end if you need to. It makes it a lot simpler. It makes it easier to do. It makes it faster to do. It is not necessary to find the least common denominator if it's going to take time or if it's too difficult. Just find a common denominator. And the easiest way to find a common denominator is to multiply these two numbers. So in this case, 2 times 3 would just be 6. So we know that we want these two numbers to become of 6. We want the denominator to become 6. So to find the common denominator, the quickest way is to just multiply your denominators, because that will always give you a common denominator if you multiply them. So we can't just say, okay, well, we're going to multiply them when we're done. We have to change what 1/2 is. So in order to do that, the question is, well, how would I make 2 become a 6? Well, I can multiply by 3. So I'm going to multiply by 3. And you've probably heard several times that what you do to the denominator, you also have to do to the numerator. But why is that? Why do I have to multiply the denominator by 3 and the numerator by 3? Well, as I said before, when you can change the way these look, but it has to stay the same value. And what is 3 divided by 3? 3 divided by 3 is really just 1, right? We talked about that with division earlier. 3 divided by 3 is just 1. So since it's just 1, this is 1/2 times 1. Well, it's 1/2 times 1. Anything times 1 always stays the same. So that's why we have to multiply the numerator by the same thing we multiply the denominator with, so that we're really just multiplying by 1. And when we multiply by 1, things stay the same. So with the 1/3, we also want to change the denominator to 6. So 3 times what gives us 6? Well, that's 2. Again, what we do to the denominator, we must also do to the numerator. And now at this point, we can multiply. Now, we haven't talked about how to multiply fractions yet, have we? Well, let's talk about how to multiply fractions so we can finish this addition problem. Well, how do we multiply fractions? Well, to multiply fractions, you multiply the numerator times the numerator and denominator times denominator, and that's it. So 1 times 3 and 2 times 3 in this example. So we will end up with 3/6. And for the other one, with 1/3 times 2/2, we can do that here. So 1/3 times 2/2 would just be 1 times 2 and 3 times 2. So we would end up with having 2/6. All right. So that means our problem, we end up with 3/6 plus 2/6. Because 1 times 3 was 3, 2 times 3 was 6, and 1 times 2 was 2, 3 times 2 was 6. And we can add as we did earlier. We have the same name, so we can add them together, and we end up with 5, 6 being our answer. All right. Well, that was quite simple. We already talked about how to multiply fractions now. We've seen how to add fractions now. Now we want to look at subtracting. So let's subtract some fractions. Well, we already said in the previous video that subtracting fractions is the same as doing negative addition. Sorry, subtraction is the same as doing negative addition. It always is the same as doing negative addition. So when we're looking at fractions, it's still going to be negative addition. So if I were to have 1/2 minus 1/3, that means I can do the same thing that I would have to do if I did addition. Well, we just did the addition earlier, right? So if I'm going to add 1/2 and 1/3, I would have to have the same denominator. So if I'm going to subtract 1/2 and 1/3, I need the same denominator because they still need to be of the same type in order to add or subtract them. And we already talked about how to do that. The quickest way is to say, okay, what's 2 times 3 to find a common denominator? Common denominator of 2 and 3 would be 6 because 2 times 3 is 6. So I need to change the denominator to 6. 2 times what will give me 6? 3. And what I multiply the denominator by, I need to multiply the numerator by. Go over here. We're going to do the same thing with 1/3. And so we have 1/3. In order to change 3 to a 6, I need to multiply by 2. And what I do to the denominator, I do to the numerator as well. Multiplying fractions, we're still used to doing now. We know we just multiply numerator times numerator, denominator times denominator. So 1 times 3 and 2 times 3. 1 times 2 and 3 times 2. Okay, well, 1 times 3 will give me 3. And so I will end up with 3/6. And 1 times 2 gives me 2. And I end up with 2/6. Now they're of the same name, and I had 3 6 to start off with, and I take 2 of them away. How many 6 do I have left? 1. So 1 6 becomes my answer. 1 out of 6. 1 6. And that's how you subtract fractions. Still no different. Well, let's say that one of these was negative. Doesn't matter which one, just so that we can see that we still can do this with the negative numbers. I'm going to make that a negative. We still need to do the same thing that we did before. We still need to have common denominators. And so, once again, probably should have left it up there, but we would need to get these both to be 6. So let's skip ahead a little bit. How would I make this 6? I would multiply this by 3, so I do the same to the top. And how would I make that 6? I would multiply by 2, so I do the same to the top. So I have negative 3 minus, negative 3 6 minus 2 6. Okay. Well, we said when we're subtracting, that's just negative addition. So negative 3 6. Change this to addition and change the sign on the second one. So this becomes negative 2 6. And now we can add those two together, and negative 3 plus negative 2 gives us negative 5 over 6. So even with the negatives, it still keeps the same rules that it did with the integers. Because these are just integers dividing. That's all fractions are, integers dividing. So we've looked at adding fractions. We've looked at multiplying fractions. We looked at subtracting fractions. All that's left is division. And this seems to be one of the more difficult things for people to do. So I'm going to talk about what it actually is first. Okay. Well, let's look at 3 divided by 3. Okay. Well, we've seen that already. We know 3 divided by 3 is 1. We've known that for a long time. Okay. Well, instead of looking at this as 3 divided by 3, let's just say that this is 3 times 1/3. Is it? Yes, it is. 3 divided by 3 is the same as 3 times 1/3. All I did was undo this as if this was multiplication between fractions. That 3 doesn't look like a fraction. It's just like a whole number. Well, if I put it over 1, it looks like a fraction now, doesn't it? Because remember, fractions were just integers dividing. And so 3 over 3 is the same as 3 over 1 times 1/3. Well, why show it to you that way? Well, because 1/3, what's this relationship with 3? If we see these two fractions next to each other, multiplying it usually makes it quite simpler to see that all we did was flip it. This idea of flipping it is called a reciprocal. Okay, so reciprocal, where you reciprocate something, you give it back or you turn it over. So you're flipping these numbers. So you're changing this number by flipping it. That's how you find a reciprocal. Now, again, we're talking about division. So why am I talking about this? Because when you're dividing, you're really taking the first number, the numerator, and you are multiplying by the reciprocal of the denominator. So 3 divided by 3 is really the numerator, 3, times the reciprocal of the denominator. I'll write that out, reciprocal of 3, which is just 3 times 1/3, as we saw earlier. And that would still be 1. Okay, that was with looking at integers, though. Let's look at just fractions, a fraction divided by another fraction. So I'm going to do 1/2 divided by 1/3. So 1/2 divided by 1/3. All right. Well, 1/2 divided by 1/3, according to what we just did, the numerator, which in this case would be the 1/2, It's going to stay the same, and we're going to multiply it by the reciprocal of the denominator. So the reciprocal of 1/3. Of course, you won't have to write out the word reciprocal and things. This is just so that you get used to the idea that you are taking the reciprocal of the denominator. Okay? Well, this would just be 1/2 times, remember reciprocal means you're going to flip the fraction, so we get 3/1. And we know how to multiply fractions. We multiply numerator times numerator, denominator times denominator. And so 1 times 3 is going to be 3, and 2 times 1 is going to be 2. And so 1/2 divided by 1/3 is 3/2. All right, let's do one more together, and then that will actually be everything with fractions. So we're going to do 5/6. 5/6. And we're going to divide it by 7/3. 7/3. All right. Well, we already know we're going to take the numerator and we're going to multiply by the reciprocal of the denominator, meaning we're just going to flip the denominator. It was 7/3, so it's become 3/7. And now we're going to multiply across. Multiply numerator times numerator, denominator times denominator. And 5 times 3 is going to be 15. And 6 times 7 is going to be 42. And that's it. Well, I said that would be it. There's one more thing that you can do with fractions. And it all has to do with changing the way it looks. If we were thinking of this as division, which fractions are just division, you would notice that there is a factor here that both of them have. They are both divisible by 3. So that means that this is just some number times 3 times 3, which is what we had to do earlier when doing addition between fractions and subtraction between fractions. You have to have the same name. So we multiply it by a number divided by itself. We multiply it by 1. So that means we can reduce these fractions by getting rid of that. Why do that? Is it necessary? No, it's not always necessary, but majority of the time it'll make things easier to look at. It'll make things easier to understand, because if you're looking at smaller parts, say 1/3, 1/3 is a lot easier to visualize than saying 3/9, or even going even further, maybe saying 9/27. It's kind of hard for me to think of 27 different things and taking 9 of them when I could just think of 1/3 of it. So in this case, what is the common factor that we see? We see that both of them are divisible by 3. So that means that I can take out a 3 from both of them. So this is really 5 times 3. And this is really going to be 14 times 3. And in this case, I know I have 3 divided by 3, or let me change it actually to 5/14 times 3/3. So I just broke up what you would normally have with multiplication of fractions. You would have numerator times numerator, denominator times denominator. So I went reverse and I made it a numerator and a denominator times a numerator and a denominator. This, we talked about earlier, 3 divided by 3 is just 1. So a lot of times you were taught, oh, that cancels out. I don't like using the word cancel out, because generally when things cancel out, it's dividing by 1 or it's adding 0. And most students will just think canceling out is adding 0. This is not 0. 3 divided by 3 is 1. It's not 0. So I want to clear that up now. That this goes away because this is the same number divided by itself, so it becomes 1. And if you multiply times 1, your answer is going to stay the same. So that is everything with fractions. We have multiplied them, we have added them, we have subtracted them, we have done division with them, we've seen how to simplify them. And if you have any other questions, please feel free to contact me again at christopher.stevens@southmountaincc.edu. I'm here to help, and I will see you again soon.